Jeff Erdman, E.D.S. Shandon. Welcome to our video this week. We've got some new content. Finally, we've got some machining. I'll show you a little bit of the shop. And we're going to be using the Bridgeport for the very first time. I just cleaned her up this morning, wiped her down. I didn't do a thorough job, but as you can see, she's still a little bit dirty. Cleaned her up, got the dust off of her, and got everything plugged in and running, and we're about ready to get started. So we have a little item here that we need to make. We need to make a couple of these things. I'll bring it up forward so you can see what it is. And basically what this is a bracket for a pivot. Get back so you can see me here. It's a bracket for a pivot, and it has quite a few interesting features. If you look this way, you can see it's hollowed out. It's got a radius on the top. It's got a radius here, a radius here, a radius on the inside here, and some little slots along these sides, and a radius on the inside past this flat bar right here. So this side is radiused on the inside as well, and it has to be, because it's fitting onto a panel that has that radius, and it has to fit up over that radius. So anyway, there's some interesting features on this. So I'm not a great machinist, but we're going to test my skills. This is really a die cast part, probably zinc Zamic or something like that. And that would be the preferable way, is just to buy one, but this is an ancient panel system, and we couldn't resource it. So they need to have this by Monday. So we've got 2 of them that we have to build. So we're gonna make these little puppies here with the Bridgeport. I thought that the Bridgeport would be a lot faster than trying to mess around with the Ajax. It's a lot heavier machine. It's harder to move about, heavier heads and all that sort of thing. So I think we're going to try it on the Bridgeport and see how it works out. Okay, to start this part, as I mentioned, we've got a lot of different features on this part, and if you notice, the walls on this are pretty thin. They're the walls on it are really thin, with a lot of different little features within it that have to be built into this. You can see these slots in here. That's for a plastic part to fit in and tie in with this. It's kind of like a key. And so at any rate, I need a lot of strength. So I'm using 20-24 aluminum instead of 60-61, and it just so happens that I have a bar of it that's 1.5 by 1.5, just about what I need for this. So what I'm going to do now is go on over to the bandsaw and cut off a couple of pieces of the proper length. I think what I'll probably do is cut off 4 pieces. I only need 2 of these, but I figure what I'll do is I'll just have 2 others just in case I miff up. So that happens with me. So that way I can have a part that I can proceed with. So we'll go ahead and we'll do it that way. I'll meet you over at the bandsaw. Okay, this is my Turn Pro BS250 horizontal bandsaw, and we've got our part, which is right here in the bandsaw now, and this is my stop. So this rides on this rod right here. You can set it whatever area you want to. You can move this back and forth, swing it in, out, whatever. For whatever, this adjusts back and forth this direction as well. So it gives you a lot of capability as a stop for this saw. And you can also extend this rod and have this stop run way out. If you were cutting lineal lengths of something like 12 footers or something like that, you could run this out as far as you wanted to and use this guide as your stop. Just put in a different rod. So pretty cool. A nice feature it has here, and it helps save a lot of time. This is a hydraulic downfeed, so it feeds. It has like a valve in it so that it allows only so much hydraulics to go out at a time. If you open it wide up, it's like opening a faucet. All of a sudden you get a rush of fluid. Well, then it allows it to come down faster. So you can control the speed of this head as it comes down and cuts your metal for your feeds. And so that's pretty nice on the saw as well. This does have its own coolant system. I won't be using that with this. This is aluminum. What I'm going to do is go grab some WD-40 and just use WD-40 cut in aluminum. And secondly, I haven't gone through the pump yet for this. I pulled it out one day, looked at it, it was running, but it wasn't pumping. So I don't know if there's something plugged in the lines or whatever. I just haven't had the time to go back into it and figure out what is stopping it from pumping the fluid up to the through the line. So I'll figure that out sooner or later. But in the meantime, it's been a great saw for us. We use it every single day since I bought it. It's just been the #1 saw that we use here. We used the horizontal bandsaw before. I mean the vertical bandsaw quite a bit before, and the chop saw, cutoff saw that I had with the carbide blade for cutting steel and what have you. But it's a lot less expensive to use a bandsaw. You can set it up with your guide. You can walk away while it's cutting, come back, reset the part. With the chop saw, you're there. You have to stay with that and bring the feed down to it. And carbide teeth, if you're not smooth or whatever, you eventually lose those teeth. To sharpen them, it costs a lot more money and what have you. So I found that this is the best value. A lot better than chop saw. If I'm doing something in a real hurry, only one cut, I'm going to slap it out real quick, I'll go to the chop saw and knock it off. But if I'm doing even thicker material, I'd prefer cutting it on here. If I'm doing anything that's heavy, it's here. If I'm doing my door frames, I'd rather do it on this than the chop saw or the radial saw. In fact, now that I've got this, I might end up selling my radial arm saw that I had, because that was basically for cutting our jam stock, and this will do that. And the footprint is about the same. Actually, the radial arm saw is probably a little bit bigger, and and a little bit more dangerous, the radial arm saw is. So I'm probably going to get rid of that, I think, and if I can. I doubt if there's very many buyers for those anymore. It's not one of those things that a lot of people use anymore. And that one is designed for cutting steel. So it's not a wood cutting machine at all. It's a little bit slower speed to cut steel. So anyway, so that's it on saws. Well, let's go ahead and we'll start cutting this thing. So I've got this turned on. Automatically shuts off. Just bring this forward to my next my stop. Pull that forward, lock her down. Start my next cut. Walk in there. That's that. Not too bad, huh? Uh-oh, I got one more than I intended. Oh well, okay. We have one extra just in case I need it. Okay, I'll bring you back to the mill. Okay, we're all set up. I've trimmed the vise in. I've set my block. I've got a stop in here so we can do one and then go do the other. I found my zeros here, here, and my height. I brought it down to 0.90. That's the depth I want to go with my first cut. And so we're going to take this down to 0.90 and take it back to 1.5. So we're going to go ahead and set it in 0.47 so we make sure we clean up this edge. So we'll go ahead and bring her in. And make sure that we're going at our lowest rate, 0.75 on my feed. And once I hit 0.15, then we'll stop her. This front edge and this edge are both going to be radiused before we're done. Okay, you might have noticed I had a little problem with my brain. Math isn't my best suit. I can waddle through it, but it takes me a little while. So what had happened is I started machining this, and the cut that I made was correct. There's nothing wrong with that. But what I failed to remember is that this part is wider than this part. Excuse me. Okay, had to sneeze. Didn't want you to see that on camera. Anyway, at any rate, this part's width is about 1.25 inches. It's a little bit off on that. The material I'm using is 1.5 inches. I'm going to go ahead and leave that extra width on this material just to give it that little bit of extra strength. And this part here, these sides do not have any impact if they're a little bit wider. I'll just chamfer this back in to that part, just like this is chamfered now, and it'll work just fine. So, and it'll make these walls thicker here and here, which will give it more strength. And that's what broke originally. The thin walls on these broke right across here. So, and this part broke off from this part. Let's see if you can see that. The upper part broke off from the bottom part where this hole is. So, so now we're going to have a little bit thicker walls on the two sides, which will prevent that from happening in the future, hopefully. So I forgot to calc that in. So I was going through the numbers there, and nothing was making sense to me, and then I remembered why. And so at any rate, just a little brain fart, I guess that's what you call them. And I went down, I sat down, I thought this is a little bit too intricate for me to do by the seat of my pants. And that's what I was trying to do. I was just trying to look at it and say, okay, I'll go this far, go that far, I'll make it work. But after I started getting into it, I thought, yeah, I better sit down and do the math and make sure I do it right. So I sat down and did the math. So I'm back now, and I've got several pages, and I kind of took this and started with a sheet 1, and with the first thing that I was going to accomplish with a specific bit. And then as I accomplish that and I change the bit, then I'll go to page 2 and do that. Well, actually the second bit is on page 1 still. It's a second process. So I'm going to be using a 1/2 inch bit, then I'm going to change to 1/8 inch bit. And then I'll probably have to go over to my Ajax mill and set that up because I'm going to have to use a 1 inch bit to do some of the work in this part. So, and then I'm going to need to use my little brain dead again, but the little round table that you words left me. Anyway, the little round table that you can spin around in circles. For lack of remembering what it's called. I'll remember later on. That's Alzheimer's or senility or something, I don't know. So anyway, so that's what I've done is I've broken this down into several components so that I can, and I've actually given what I'm going to be reading on my DRO so that my starting points, my end points, that sort of thing on the DRO, so that I accomplish this the right way. And that way I won't mess up by thinking I thought it was this number, but it was this number. It's all down on paper. I can refer back to it, and I won't make a mistake. And hopefully, that's the thought. Anyway, so let's get back to milling, man. I'm excited. Okay, thank you. Okay, so for the through hole that I have to run through here, I've got my y-axis located. It needs to be 0.7812. So we'll probably make it 7813 or thereabouts. It's hard to get that 10 thousandths of an inch mark right. So anyway, we'll try to hit that number with it, and that'll be the start of the Y, and then the X should be 1 inch is where I start. This gives me the finish number that I'm going to finish at. This is 0.21875, so it'll be 2188. Or hold it, no, I go 4 digits. So 2188. And then on my X, I need to go to 0.1406. 0.25, so that'll be 6.3. Okay, so that's what we'll do. We'll go ahead and we'll position our bit in the proper areas. And you know, before I begin milling, I'm going to turn on the fan again. It's pretty hot in here. Okay, so I've got, you can see my x-axis is 1 inch. My y is 0.7882. Oops, that's wrong. It's supposed to be 781.2. Let's try to fix that. Good thing I was showing it to you, huh? 8. There we go. The 7812, and for my y-axis and my x-axis is 1 inch. And basically what we're going to be doing is we're going to be going all the way through this part and to cut a square hole. So, I'll bring you forward a little bit, and I just want to let you know that this is the way my brain works. Rotary table is the part that I was trying to remember but couldn't. So, we're going to be cutting this part right here with a 1/2 inch bit, and I'll try to stay out of your way. Get this focused, and we're going to be basically taking a plunge down and then doing our X and Y axis. Okay, so let's go. See if I can avoid getting in the way there. 5 parts made now, or not made, but the first process done. So here we go, all identical. I'm not too worried. You might have wondered, well, why is he leaving that rough cut on the front and the back? On the front and the back. I have to show it to you in the camera. I'm just looking at them. You know, on the back it's a little bit rough cut. It's a bandsaw cut. And I'm not worried about that because there's a radius on both these edges. So that is going to be taken out. So I'm not worried about it whatsoever. So the next process is to get an 1/8 inch bit in here and trim this down all the way around. And then we'll start the back side and the features on that. So it's late, and it's time to head in. Probably about 9 o'clock. I've been here since about 6:30 this morning, cleaning the shop and what have you. Now, what I'm going to do, you see my DRO there. Right now, it's not on my 0. So what I'm going to do is set everything on 0, then I can turn everything off, leave it, come back, turn it back onto the turn it back on and it'll be set on 0. Okay. Getting that 2 off is going to be the pain right there. There we go. Now when I lock the bed, it'll change. Nope, it stayed. No, it changed. There we go. So we got the X axis zeroed. We've got the Z axis zeroed already. Now we just have to get the Y. So we're going to take that to 0. Oops, went too far. We'll lock the bed there. Now everything is set. I can turn off everything, and when I turn it on, I'm exactly at all my zeros for my next process. So I'll leave the magnet on there to stop, and it'll be just ready for when I start tomorrow. So this is Jeff Erdman signing off. Thanks much.